So a maximum is anywhere between 1 and 6 electrons once we start having electrons traveling in three-dimensional figure of path. Okay? All right. Now, that represents this whole area right here. These are all p electrons. In fact, on your periodic chart, you probably should write p electrons above these 6 columns and s electrons above these 2 columns over here. So s's and p's, and then there's this gap right here. And that gap is represented by the next higher L value, which is 2. Now, it turns out that the shape of these paths are like three-dimensional clover reliefs stuck between axes. 4 of them. And then there's one that's shaped like another dumbbell going straight up and down and has a donut shape around it, which I'm not going to draw. So we're going to simply call them clover leaf shapes. So let's take a look at that. So in this particular case, when L equals 2, okay, let me finish this thought here. When L equals 1, this is three-dimensional figure 8 paths. And we call these S electrons when L equals 0, and we call these P electrons when they travel in that shape, right? Whenever L equals 1. So the next one is when L equals 2. This is where we get the clover leaf shapes. Three-dimensional clover leaf shape. And we call these d electrons. Now those d electrons are found right here in the middle. Okay? If we look at this row right here from scandium to zinc, there's 10 columns right here. We talked about this in the levels before. And we said that the levels in which we find these are actually one row late. It should be found over here in the 3rd row. But it takes more energy to put electrons in the 3D level than it does in the 4S level, or whatever you want to call it. Okay? So, these 10 right here, just like we said on the previous video, are one row late. So, right above that, put D electrons and then parentheses 1 row late, if you don't have it already. You probably should have 1 row late already. But these are 1 row late. So, and we'll discuss what that means as well, but it takes more energy to fill these in than it does for the 4S. So that's why we have that little skipping of levels. We went from 3D, the P's here, and then we went with the S's, then we went to the D's. Okay, so S's for these 2, 6 for these, P's for these 6, and D's for this right here. And then the last one, and we haven't talked about yet, but there's one more that we have found. Now, there theoretically are others, if we get that far, is when L equals 3. And when L equals 3, this is what I call a weird shape. It's really kind of difficult to explain. It's kind of like a blob here, and a blob here, and a blob here. It's an interaction between these electrons and the protons, where things get so crowded, now they tend to get pulled closer to the nucleus than they'd like to be. So if you want to see a picture of what it kind of looks like, you go online and take a look at it. There's no adequate way of describing all the shapes of the 14 or the 7 different paths involved in the 14 electrons. We call those electrons F. Now, where does the number 14 come into play here from what we talked about last time? Yeah, these bottom 2 rows right here. We'll take the lanthanum and actinium, if you don't have it filled in up here, put them up there, and then the remaining 14 columns represent F electrons. The highest energy electron in each of these is an F electron. So your job today is to be able to find an atom or an element on the periodic table and tell me what level and what orbital shape is the highest energy electron of that element. Now, when we say that, we're going to use S, P, D, and F as that explanation. Well, again, put F electrons, say, somewhere down here. You should already have that it's written, you should have written that there's 2 rows late for these. If not, put it in there. And now let's take a look at how we can use that in predicting the level and shape of the highest energy electron. We'll start with niobium. So let's find niobium. Niobium is element number 41, Nb. Not one of the ones I asked you to remember, but it's there. The question is, what level? Well, what kind of element is that? Well, what kind of electron is that? Well, this is a d electron. It's in this middle 10 area, right? It's in row 5, but we know d electrons are 1 row late, so it's level 4 in row 5. And it's in this group of d electrons, so the answer is it's a 4d electron. The highest energy electron in niobium is a 4d. Next one. What is the level and shape of the highest energy electron in nitrogen? Well, let's find nitrogen. Nitrogen is here, element number 7. It is in the 2nd row. And these 2 columns and these 6 columns, the row and the level are identical. So this is a 2nd level electron. It's in the group of 6 on the right. The shape that we call this is a P shape. It's a P electron. So this is going to be 2P electron. Next one. What level and shape is the highest energy electron in neodymium? Neodymium is element number 60. It's right here. Okay, now again, remember, the La and the AC don't belong here, they belong up here. They call these elements here, they call them the lanthanides because they follow lanthanum. And they call these right here the actinides because actinium actually belongs there. So we ignore those 2 right there. But we do notice that neodymium is in this group of 14 down there. And this row right here belongs right here, and that's row 6. Okay? Now row 6 means, does that mean it's level 6? No, that's only for the S's and the P's. These are F's here. They're in the bottom 14. And there are 2 rows late, so if they're in row 6, subtract 2 from 6 to get 4, this is going to be a level 4F electron. 4F is the answer that we're going to get. So the highest energy electron of neodymium is 4F. We'll do one more and then we'll get you going on your own there. What level and shape is the highest energy electron in cesium? Well, cesium is in that left 2 columns. So those are S electrons. And the nice thing about the S electrons is that the row and the level are identical. You count down there, if you got numbers on the side of your periodic chart, use that. That is row 6. So this is going to be considered the highest energy electron is going to be a 6s electron. And sure enough, it is. Your practice problems, level and shape of the highest energy electrons in these 5 elements. Good luck.